Hi, welcome back. Well, I've completed all the recapping of the radio, and it was quite a chore, as you may have seen in my prior videos. I was going to recap everything anyway, but what I found out was every single resistor was way out of tolerance. So there's definitely something going on with this radio. I had to, as I mentioned, to rewire so many things, recap everything. I probably replaced 5 or 6 wires easily, and I had to open up some of the transformers. They have transformers, which I hate doing, but I did it anyway. So what we're going to do now is we're going to turn it on, and we're going to see what we get. I'm kind of going to show you what I go through for that process, to show you how I start up at a very slow low voltage, and we build our way up from there. Be right back. Okay, I am back. So the way I have this set up right now is I have all my things go through an isolation transformer, which is in the back there, and I have it hooked up to a variac, and the variac's hooked up to the radio. So I have it set right now for almost 50 volts. And I don't have the radio on yet, but you can see we have a little bit of current, no power. I'm going to turn the radio on now. If we see some of the numbers spiking up there, we're going to quickly shut this off. Okay, I turned it on. I do see the bulb on the radio dimming, starting to glow a little. Not enough to really get it going because just too low voltage. Let me get that in focus again. So far looks good. We don't see any problems. We don't see any high amperage draw. I'm going to move it up a bit more. We're going to move it up to about 60, 61 in this case. There's no power draw yet. The bulb on the radio is still glowing. Obviously there's no sound coming out of the radio yet. But the numbers look good. I don't see any smoke. Raise it a little more. Up to about 82 volts now. Drawing 0.03 amps. I'm actually hearing something come out of the radio now. Okay, that's a good sign so far. And let me bring it up to the full voltage now, which is generally about 119. Okay, so at 119 we are drawing a tiny bit of power. This is the numbers that are expected. So that's a good sign. What I don't like so far is that I actually hear a hum in the radio. And I replaced all the electrolytic capacitors, so that should not be humming like that. Let me see if I can tune something in. Let me back out a little so you can actually see what I'm doing. And just, by the way, I have one hand in my pocket while I'm doing this. There's not a chance I'm going to get shocked. I don't like that when I'm touching these things. I get that, so I have to see what's wrong with that. So now we're going to go through some troubleshooting. I'm going to set it up. I'm going to recheck to make sure everything's connected. I'm going to check the voltage, AC and DC. And we'll try and troubleshoot from there. I will be right back. I have it all set up to do some troubleshooting. I just want to show you the schematic one more time. And we're going to go over the same steps we did at the very beginning to make sure that everything still has connection to it. Now the radio is unplugged, the power's off. So this is just doing some testing as I did in the very first step. So first thing I'm going to do is I'm going to check the power switch. I'm going to turn it on so we actually have continuity. And we have 0.05. I need to zoom out a little bit, I think, so you can see that. Let me move this down a little more so we can see things a little better. Okay, there we go. Should be able to see it. So power switch, continuity is fine. I would expect it because I could raise and lower the volume. I'm checking the antenna coils back here. This should be the coil to that one. There we go. .8, 0.9. When I look at the schematic, it says 8 ohms, so we're fine there. Now I'll also check the transformers, starting with the second one. Okay, I'm checking the schematic to see where it belongs. So as we showed in the prior video, we're just simply going to make the different connections here to make sure we're still getting what's expected. So this one is green going to pin 4 of the 12SQ7, and the black going to pin 5, same one. That was SQ7. Yes. Actually, I got the wrong. Let me check it again. It's the green coming out of there. And the bottom one coming out, which actually is yellow, goes to the power switch. Alright, so the green that comes out of here goes there. The yellow goes to the power switch down there. $17. And what's expected is 16 amps, so we're fine there. Now let's go to the other side coming out, blue and red. The blue comes out to 12SK7, pin 8. And the red will come out to pin 6 of 12SK7. That's right here. Pin 8, pin 6, 17. Just what we expected. So that's good. Let's do it again so you can... Good, so that's good. That means I didn't break anything when I opened up that transformer. Moving on to the next one. This next set is expecting 7 amps. This is the first IF transformer. And the green wire comes into pin 4 of 12SK7, and then the black goes to ground. So 1, 2, 3, 4, and then we can go to ground. I can hit that here. That's just a little high. Let me get a little better connectivity on that one. Let me hit it over here. 8.9, if you can see that. 8.9. And I mentioned they're expecting 7, so that's fine. And then finally the last one is the input on the first IF transformer. That's a blue and red wire. That goes to 12SA7, and that's pin 3 and 4. So 12SA7, pin 3 and 4. 1, 2, 3, and 4. 8.3. Good, and that should be 7, so that's close enough. So at this point, anything I've touched from the standpoint of corrections and changes should not have made a difference to the important aspects. I'll quickly check these guys here. I didn't check the schematic, what it should say, but this says 7.5, 7.6, and 7.5 is the correct number for that. Good. So at this stage, everything actually is fine from the components that I changed. What I'm going to do next is actually measure the voltage through the AC and DC. So I'm setting up right now to the negative, the ground voltage, the negative, and I will use the positive voltage. Get these wires out of the way. Good, so I'm going to plug the radio in. I'm going to turn it on. I left the power switch on already, so it is going on. If we look at the schematic here, this section here is the power supply, and what we do is we measure from the different pins coming in and measure each pin to see what the measurement is. So if you're starting at 120 volts, which I think I'm set for right now, I'll leave it at that because it's easy to do math. Starting at pin 2, I should get 120 volts on the input. The output of that is pin 7. So what you would expect is 120 minus the rectifier tube is 35 volts. That's the first two numbers. So 120 minus 35, you would be expecting that you would get 185. We'll see. Okay, so I'll start with pin 2, and you can see this is where the... I do not like that sound. Let me move this over to DC voltage. I'm sorry, AC voltage. 120, almost spot on, so that's fine. That's pin 2. Now following along the schematic, it enters this one and leaves at pin 7. And I said I was expecting 85. I'm sorry, I was doing my math wrong. This is just about 90. So that's 35. That's actually a tiny bit high, but that's okay. I would have expected to take the full 35 volts off, which should have been 85, but that's only a 4 difference. I'm not that concerned. Next, it moves on to the output tube, which is the 50L6 GT. And that moves into pin 2, and that's over here. Trying to find the pin number. This is such a tight tube, it's very difficult to see. Okay, so you saw from the other, we were on 89. Now we're back to pretty much where we were at 88.6. That's what we would expect coming in and leaving. $37, because that's 50, right? So 50 minus, I'm sorry, 89 minus 50. Bottom line is we're getting around the right voltage at that point. So leaving this I'm a little hesitant because it's so difficult to see. I don't want to get my face in the camera. Okay, let's try it again. Oh, that's not it. Okay, I need to adjust a little, get more light on the subject here. Hang on a sec. It's too dark. Pin 2, 88.7, good. 2187. Pin 7, 37. Which I would expect, give or take. Next is the 12SA7. That's next to the 35. And that's coming in at pin 7. So there's the 37 we saw before. And exiting at pin 2. .24. So we lost about 12 volts, which we would expect to do because it's a 12 volt tube. Next is 12SK7. He comes in at pin 7. So there he is at, whoops, 12, did I say 12? SK7, yes. 12SK7, coming in at 7, leaving at 2, okay. So we have 12 volts there, and then leaving at pin 2. And actually I said that backwards, coming in at pin 2, right, which is 24, leaving at pin 7, which is 12. So we're down to 12 volts left with one tube to go. And that's 12SQ7 coming in at 7, leaving at 8. So he's coming in at 7. There's the 12, leaving at pin 8. We should be down to 0 here, which we are, right? So our AC voltage is fine throughout the radio. So whatever the problem is, it is not that. I lowered the volume so you wouldn't hear that background noise, by the way. Okay, so now we're going to check the DC voltage. Unfortunately, this particular schematic does not have all the information that some of the other ones have, but it will give us the important information on the DC voltage. So if we look around to see where it comes in, it will let you know on these tubes. Like on the output tube, this should be 100 volts right here on pin 3. Pin 4 should have 80 volts, and this is all DC, by the way. We did AC already. And then pin 8 should have full volts. And we'll just look through different parts of the schematic to see if the voltage looks good for the DC voltage. I have a feeling it will be because we seem to be getting power, so, but we're just going to check to make sure. So I moved my thing from AC to DC, and I said we're going to start at 50. I'll start at pin 3 should be 100 volts. And once again, it's almost impossible to see this stupid one because there's so many things on it. 2, pin 3. 114, a little high. Not horrible, but a little high. They say that you can be off by 10 to 20%, at least according to the schematic. But a little worrisome, but not horrible. If I go down to pin 4 now, .91 volts, he should have been 80, so again just a little high, that seems to be following through. Pin 8 should give us 4 volts. and it does 4 point something, so that's fine. I'll move on to the detector tube, 12SQ7. We are expecting on pin 6, 60 volts. Oops, wrong pin. 55 volts. Little low, but should not affect it from working. That's the only DC voltage that they have on the schematic for that one. Moving on to the YF amplifier tube, 12SK7. I can see we have pin 8 should be 80. Oh, actually, it should both be 80. Pin 8 and pin 6 should both be 80. So here's pin, light it up again. Pin 8 should be around 80. 91, a little high. We seem to be carrying a high volume throughout. And then pin 6. 91. Okay. So again, it's the same issue, just a tiny bit high. 12SA7. I should be getting 80 volts on pin number 3. .91, that seems to be carrying through. And what else we have on this one? We should have a -13 on pin 5. Okay, 8765. And -4, so that's close enough. I'm sorry, it's actually, it's a little low. I was hoping to get a little more. Let me just verify the pin number. 8765. 876. Yeah, -4. That's not great, but it's still a negative voltage. I mean, we're talking about a couple of volts difference. And then finally the 12SA7. Oh, we just did the 12SA7. We actually have gone through all the pins. So our voltages seem to be fine, or within tolerance, I should say. So now I'm going to try and step through it and see what else we can check to kind of narrow down where the problem, where the fault may lie. So I will be right back. Welcome back. Kind of move this around a little, get it in the picture, so we get the idea of what we're doing here. Okay, so what this is a signal generator. This can generate a radio signal, but it also can generate an audio signal. This is an older one from, I guess, the 1960s or so. Anyway, what I'm going to do is, looking back at the schematic, I'm going to try and trace the signal where it comes in. There's two ways to do that. You can come from the antenna and just follow the signal that you would expect through the radio. Or you can start at this end from the speaker and check the speaker first and work your way backwards, which is I'm going to do right now. The first test is easy because, number one, you don't have to have power to the radio because the speaker is magnetic. You should be able to pick it up right away. So I have it hooked up to the, if I follow from here, from the speaker, it goes to pin 3 of the output tube, and then follow the negative, the black, it goes down to the output of the electrolytic capacitors. I have that set up here, pin 3 here, and negative electrolytic capacitors. Right now it's on radio, signal, radio signal. I'm going to put it to audio. Okay, and you hear that sound. That means that the output tube and the speaker, the whole output section is working fine. And that's with the radio off. For the next step, I'm going to have to turn the radio on. And let me set that up and we'll be back. I'm back in a moment. I have it set up now. There's a little buzzing in the background because I have it everything hooked up, but I don't have any signal coming in. So for this next one, we want to check. We've already checked this side of the output tube. Let's check on the input side now. So we're expecting input to come in into pin 8765, and output, the ground, would be down to the negative, which is pretty much where we had it before. They all kind of come together there. The one thing I want to mention is that at this point we're still going to use an audio signal and a radio signal. The radio signal, the way it works is when it comes in through here, the radio signal eventually gets turned into an audio signal, and this is the last stage where it goes from radio to audio. So it should be set. All I have to do is turn it on audio frequency out. And there it is. Not a pleasant sound at all. Good thing nobody's asleep in the house. Okay, next we'll work on to the next piece. I will set that up and be back in a moment. Hi, welcome back. As I was working through the radio, I found something quite interesting. I decided to start. I was working my way back through here, showing you the different aspects. I decided to go to the end here and input a signal onto the radio itself. So this is I input a 455 kilohertz signal. So I have the signal generator set for 455. Let me turn it on. I have it hooked up to the antenna. Input coming to the antenna and to the negative. You can hear the signal. A little off, I'm not sure what that is. But it is right at 455. So the radio is picking up a signal for sure. So I'm going to have to sit back and just look at everything I've done before to make sure I use the proper capacitors, the proper resistor, all the same measurements that I've done. I just want to go back and double check, and I'm going to double check my wiring. So hopefully we'll be back, probably not today, but another day to try and figure out what's wrong with this radio. Thanks so much for watching. Hi, I'm back again. I said I wasn't going to be back for another day, but what I decided to do was try something out. I have a transmitter. This is actually an AM transmitter. I have it hooked up to my iPhone, and I can use this to transmit AM signals with the antenna. So I said, let me see if I can, this is a strong signal because it's so close, and let me play a song. And I hooked it up to the antenna, and I'm just trying the different things. You can hear a little here, hooked up, but that's it. Even though I'm right next to it, normally the signal is so clear. I'm actually going to bring it over to the oscillator and the tuner. And you can hear it here as well. So in my mind, there's definitely an issue between in the loop antenna area. So I don't know if there's a break in the antenna. I thought I'd check that already. Or there's a problem with the oscillator. But we'll check those out. At least I narrowed it down to a spot where I can look, and we'll be back. Thank you.